Alright, so in this problem I have m minus n squared is equal to m squared minus n squared. So to solve this problem, I'm going to first start by rewriting m minus n squared. And I'm going to rewrite this to m minus n times m minus n. Now from here, I'm going to expand this by multiplying these two. So to multiply these two, I'm going to first start by distributing the m. M times m is m squared. M times negative n is negative mn. Now I'm going to distribute the negative n. Negative n times m is negative mn. And negative n times negative n is positive n squared. So I have this is equal to m squared minus n squared. Now, I can do a few things here. I can first start by subtracting m squared on both sides, so this way these two m squares cancel out. And now I'll be left with negative mn minus mn plus n squared is equal to negative n squared. Now negative mn minus negative mn is equal to negative 2mn. And then now if I subtract n squared on both sides, these two cancel out and I get negative 2n squared. Now from here, I can divide both sides by negative 2. So then these two negative 2's cancel out, these two negative 2's cancel out, and I'm simply left with mn is equal to n squared. Now from here, I'm going to subtract mn on both sides. So then these two cancel out, and I get n squared minus mn is equal to 0. Now the greatest common factor in n squared minus mn is n. So if I factor out n, I get n times n minus m is equal to 0. So now this gives me two equations. I get n is equal to 0, which is already a solution, and I also get n minus m is equal to 0. Now, going back to our original equation, we have m minus n squared is equal to m squared minus n squared. If n equals 0, I get m minus 0 squared is equal to m squared minus 0 squared, which turns into m squared is equal to m squared, meaning m can really equal any number. If m equals 5, then I have 5 squared is equal to 5 squared. If m equals 100, I get 100 squared is equal to 100 squared. So m can equal any number if n is 0. Now for here, I have n minus m equals 0. So if I add m on both sides, I get n is equal to m. Now, if I put this back into my regular equation, I have m minus n squared is equal to m squared minus n squared, and I'm gonna rewrite n as m because they're both equal to each other. So now I have m minus m squared is equal to m squared minus m squared. M minus m is 0, so I have 0 is equal to 0. And this means that they're both equal to 0. So, now going back, what I'm going to do is do a different method to solve this problem. So method 2 is, first let's rewrite the equation. We have m minus n squared is equal to m squared minus n squared. And now this time, I'm going to again expand m minus n squared to m minus n times m minus n. And now from here, I'm going to rewrite m squared minus n squared as m plus n times m minus n. Because if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So now, as you see, we can simply divide both sides by m minus n, cancel these two out. So now I'll be left with m minus n is equal to m plus n. Meaning, if I subtract m on both sides, I get negative n is equal to positive n. If I add n on both sides, I get 2n is equal to 0, meaning n is also equal to 0. And if n equals 0, then remember how we already tried this out, m is also equal to 0. So these are my two solutions to this equation. Alright, so in this equation, I have x to the power of 4 plus x squared is equal to 20. So to solve this, what I'm going to do is first start by subtracting 20 on both sides, so we can have all our terms on one side. So I get x to the power of 4 plus x squared minus 20 is equal to 0. Now this may seem like a quadratic equation, but it's not, because we have the power of 4 as our primary term, and then that's led by the power of 2. And in a normal quadratic equation, we have 2 as our primary, then we just have 1, and then we have some constant c. So how are we going to solve this? Well, we can't factor this out by using the quadratic formula, because this is not a quadratic equation. So to solve this, what I'm going to do is rewrite this as x to the power of 4 plus x squared minus 16 plus 4. So I rewrote 20 as 16 plus 4. And the reason I did this is because negative 16 is the same thing as negative 2 to the power of 4, and negative 4 is the same thing as negative 2 squared. So now notice how I have something in the power of 4 and something in the power of 2, and they're both the same. Now I can put the powers of 4's together and the powers of 2 together. So I get x to the power of 4 minus 2 to the power of 4 plus x squared minus 2 squared is equal to 0. Now 2 to the power of 4 is 16, and 16 is the same thing as 4 squared as well. So I get x to the power of 4 minus 4 squared. And I have this plus x squared minus 2 squared. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 is the same thing as x to the power of 2 times 2, which is equal to x to the power of 2 to the power of 2. So now I get x to the power of 2 to the power of 2 minus 4 to the power of 2 plus x squared minus 2 squared is equal to 0. Now notice how everything is in the power of 2, and if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So we're going to use this property on these two groups. So I first get x squared plus 4 times x squared minus 4 plus x plus 2 times x minus 2 is equal to 0. Now we can use this property again on x squared minus 4, by rewriting as x squared minus 2 squared. So that's going to equal x plus 2 times x minus 2. And I have this plus x plus 2 times x minus 2 is equal to 0. Now I'm going to factor out x minus 2, so I get x minus 2 times x squared plus 4 times x plus 2 plus x plus 2, which is equal to 0. And notice how we can also factor out x plus 2 as well. So, actually at the start what we could have done is just factored x squared minus 4 out, but now we're going to factor out x plus 2 as well. So I get x plus 2 times x minus 2 times x squared plus 4 plus 1 is equal to 0. So x plus 2 times x minus 2, like I said, was x squared minus 4. And I have this times x squared plus 4 plus 1, which is x squared plus 5. Now this is equal to 0. Now this gives me two equations. I get x squared minus 4 is equal to 0, and I get x squared plus 5 is equal to 0. So for x squared minus 4 equals 0, I can add 4 on both sides. So I get x squared is equal to 4, and this is equal to positive or negative 2. And for x squared plus 5 is equal to 0, I get x squared is equal to negative 5, and I get x is equal to positive negative square root of negative 5, which is equal to positive negative square root of 5i.